Hello, everyone, and welcome to Scaling Testing at a Startup. My name is Arun, and I'm excited to share with you a journey that we've taken in seeding testing at a growing startup like BigSpring. I'm the CTO here, and I've been here for a little over a year. And prior to this, I spent over 5 years at Uber, several years at Google, and a bunch of other startups. And I'm joined here by my colleague, Aliisa.
Thanks, Arun. Hi, my name is Aliisa. I'm a software engineer here at BigSpring. Previously, I was on data teams at Comcast NBC Universal, and I'm really excited to be here to talk about testing.
Thanks, Aliisa. As I mentioned before, we're going to be walking you through what it was like seeding, testing, and growing that culture here at BigSpring. We want to do this in 4 parts. The first part, of course, I want to give you a background on our company, on our product, and why testing is so important for us. Second, Aliisa is going to talk a little bit about our aspirations as we kind of approach this problem, given our backgrounds and just given the best practices that we've read and aspire to. How did we parse all that in? And then I'm going to walk through a little bit about some of the challenges and pitfalls along the way and how we actually addressed this in our approach and being practical about it. And then ultimately, Aliisa is going to cover how you make this practice sustainable in your own team, in your own sort of organizations. So it's not just a project, but it becomes a process and a sustainable one in that. Let me talk a little bit about BigSpring to get started. BigSpring is, our mission is a direct path to progress for everyone. And we do that by enabling companies big and small to invest in their employees and their ecosystem, their channels, and to make them the best versions of what they can be. Our customers include companies like Facebook, Google, and Uber, and a growing list there. And we're really excited to serve all of them around the world. BigSpring's background actually started back in almost a decade ago when our founder was helping airport employees upskill around the world. And at that point, a bit of an offline endeavor. And since then, we've really sort of evolved to become a very mobile-first and a global platform supporting a lot of different languages. In fact, as I mentioned before, Facebook is a customer, and they're using our platform to upskill journalists on how to be a better reporter, how to be a better platform user on Facebook. And as you can see in these screenshots here, platform has quite a bit of few moving parts. First, we support a lot of different locales and localization. We have measurements in how you're progressing through your skilling process. There's a lot of state in getting feedback and verification. And of course, your learning journey along the way has to be preserved and recalled. So there's a lot of different moving pieces that we aspire to test. It started out very simple, of course. We had one web app talking to one backend, a simple monorepo that was TypeScript end-to-end. But of course, like any simple thing that succeeds, it becomes more sophisticated and more moving parts are introduced. In the last couple of years, we've introduced a native iOS app, a native Android app, an administrative console, and of course, evolved our web app. And then soon enough, we'll be adding an API to this as well. So we'll have almost 5 different clients talking to the same backend. All of a sudden, this backend now becomes a much more critical part of our infrastructure and one that needs to be verified, tested, and made more robust. So that's the journey we're on here. As I mentioned before, we are a small but rapidly growing team. I was excited to have Aliisa join our team and take on this testing challenge.
Yeah, I'm excited to be here. It's definitely a team effort. I hadn't done a lot of testing previously, but when Arun encouraged me to get started, that meant I had to learn all of these. So that's TypeScript, GraphQL, Postgres. I've run across a lot of these previously, but actually understanding them, writing tests for them, you have to understand both how they work and how they break. So basically, I had written 90% code coverage at one job, an integration test at a second, and end-to-end mini kube at third. But getting a whole team to align behind tests was a totally new challenge. And so it's something we're still working on. There's a few paradigms that are in industry, such as the testing pyramid, where you have this difference between unit tests and end-to-end tests. And unit tests are very isolated and small. They tell you exactly where something is broken. But in our case, at a startup, it may not always make sense to be writing a lot of very granular code, granular tests for code that may be changing as we're rapidly evolving. So what we tend to emphasize is more the user experience. So you can see we're not the only ones to do this with that inflation of the integration piece from the testing pyramid. So that's enough theory. Let's align on some North Stars. So very heavily influenced by Arun's days at Uber, we think of tests as being measurable. So you have code coverage. We think of tests as being documentation. So if you see a bug, then you can identify it and fix it and have certainty that it won't come back. It's enablement for engineers such that they can have confidence that they're not making breaking changes, and it's quality insurance for our users are having a great experience. So having come from, some of these big companies, we have a really good understanding of what testing could look like. It's really exciting. It's robust, it's resilient, it protects your code, it enables engineers to move quickly, and this is where we would like to be. However, it's a little bit more like this right now because what we have is a bunch of sand at our fingertips, and it's kind of a blank slate. We don't have a lot of tests right now, and so the questions we need to answer are, what do we test? What level of testing? What % of unit versus integration? And will it slow us down? So I'll turn it back to Arun to take a look at some of these.
Thanks, Aliisa. That's quite the contrast and vision between the beautiful castle on the ocean and a empty sandy beach. While helpful to really contrast that, we did have some tests. We did have some tests that engineers ran in an ad hoc manner, in a way where they would verify a bug or try to reproduce an issue or really measure latency or something in a very sort of engineer-driven way. Not very sustainable. Not something that would be ongoing, not something that every time I committed code that would verify if I got something right. And certainly it was a lack of enforceable documentation. So where do we want to take it? To kind of give you some color, the type of tests we had written were tests in Cypress, which verified sort of the end-to-end browser flows in some context. We also use an open source tool named K6, which is really helpful in simulating load and running various soak testing patterns depending on the type of sustained or spiky workloads that we wanted to see. But these all were purpose-built tests that verified behavior in a specific browser context or a specific load pattern. Not the same as verifying the backend is functionally doing its job and is being protected against future changes. So I call our sort of current frame of testing phase 0.1 to give it some relative versioning, not necessarily something that we were proud of in a long-term way. So we really wanted to take that to the first phase and make it much more sustainable. So to put a little bit more color and extend the metaphor a bit, here's the sort of the sandcastle we had, something that would work, but maybe a couple of waves of the ocean would, weave it away. So that's sort of the current state of affairs before Aliisa and the team kind of jumped in and kind of took it on. So let's talk a little bit about the specific bug, the specific sort of impetus when all of this kind of came to a head. Being very customer and end user oriented, a pain that we saw was a few times we had fixed a bug and it kind of recurred, and that's embarrassing and obviously a horrible end user experience. In this case specifically, we had this issue recur once, and it was sort of a moment when we decided to really squash it once and for all. And that's to do with the login screen. Like many applications out there, we have a login screen where you can log in via email. And like many mobile phone keyboards, when you start typing in something in an empty text box, it may capitalize the first letter. There's some UX tricks around it, but we felt strongly that the backend should be robust against it and should handle it in a very case-insensitive manner. Simple enough fix. We made the fix, and then through some refactoring a few weeks later, the bug recurred. And again, this is no one engineer's fault. It's an example of a fault of the system or the process where it doesn't sort of in a ensured or validated way prevent that issue. So we said, hey, this is a classic case that we want to help verify, and every time a piece of code is committed, we wanted to validate that this issue does not reoccur. Easy enough to describe, easy enough to write tests for, but of course that requires the whole stack and the infrastructure be set up. So let's take a look at sort of what that stack and infrastructure looks like. So in this diagram here, you'll see the end user here attempting to hit our web app, which normally would be an express request to our GraphQL services talking through TypeORM to our Postgres database. But of course, the end user is immediately kind of blocked in a faulty scenario, and we want to verify that that faulty scenario doesn't happen. And in order to pull that off, what we've done is introduce a Jest service that's testing against our Apollo server. And we use the Zapier integration test server. The default Apollo server made our lives a little bit harder and sort of mocking the context a little too much. Than the Zapier one, we believe, was a better sort of use of actually using the context live. And the Jest scripts actually allowed us to verify this. So this was sort of what we had sketched up on a whiteboard and sort of decided that we're going to go after this and try to really tackle this problem. So with that sort of actual bug and a particular example of a flow that we tried to build, I'll hand it off to Aliisa and have her talk through how we sustained this.
Thanks so much, Arun. Let's take a look at how we can put some of those practices into code. When we think about Jest, there's a few things to consider. One is you have the before all clause. This is something you call to set up your environment, and then you actually call your test a little later. Then there's an after all clause where you can clean up. So with before all, what we do here, for example, is we use a test connection for TypeORM to go to a Postgres server. Then we create a company. This is actually the entry point for our data model. And then we create a role profile. This is like an administrator. This is necessary because it's what's going to allow us to create a JWT token for the authentication header for the HTTP call, which contains a GraphQL request. Let's take a look at what that mutation looks like exactly. So with auth-init, it's something that has a larger resolver, not pictured on this slide. But what we do see is its test. So you can see we're describing an authentication query. It is an existing user with capitalization because we're trying to catch that error that Arun mentioned earlier and make sure it doesn't come back again. Once we get a server, we use the create test client, which is again that integration testing server from Zapier. What we like about it is it allows us to use the same context as what is used in production. Then we send in the parameters such that you can see there's my email address. The first letter is capitalized, and this is something that we're not always certain would pass if we didn't have this test. So by having this test, we can be certain that we expect it to pass, and if it doesn't, it's not going to pass our tests. So this is something very relevant for developers who are writing new code on their local machine, and we want to make sure that when they write code that it's passing such that they aren't making breaking changes. But how do you scale this across a team? So what we do is we use GitHub Actions. First, we do a git push, and under the GitHub Actions, what it does is it spins up its own Postgres service and runs the testing suite that would be run locally. This is very important because it's a insurance that a branch passes tests before they go through a pull request and merge. So you're essentially preventing bugs pre-production. As you can see, it's a simple git push, and the time doesn't take too long. It's only 2 minutes and 13 seconds. We have two pieces here. The first one is init, and that is basically pulling down our main development branch. It's pulling all the node modules into a cache and making that available in the environment such that when we run our test, it will actually use the branch that needs tests run against it. It will pull down all of those libraries it needs in order to run using that cache. And then it will set up services provided by GitHub Actions. One is a Postgres service and another one is a Redis service, which is relevant to our backend architecture. Once we have this Postgres service set up, then we actually restore the schema from our production database. So we can be pretty well certain that we are doing a true integration test because we're testing the same environment as our production environment without making our production environment directly vulnerable to such tests. We continue along this track and restore base data to this test Postgres, and then we continue to run the tests themselves. And that's where we go back to those last couple slides you saw where we do the before all, run the type ORM to create the relevant data such that each test is isolated, independent, and we clean up after each test. So this will run on GitHub Actions very similarly to how it would run locally. As you can see, we still have a long way to go. This is our percent branch coverage, and this is just keeping in mind that we were going from basically a no Jest test infrastructure to a brand new pipeline. And so what this is to show is that we're laying the groundwork for lots of developers to be able to document their own bugs and have confidence in their own code moving forward. So we are really excited to see this continue to grow, because even a number that isn't 100, by measuring, that means we can improve. And these tests provide the ability for measurability, again, to be able to improve, documentation to be able to catch bugs once and not see them again, enablement in order to let a new engineer like me get onboarded quickly and understand the code base from an end-to-end perspective, and quality assurance to ensure a great experience for our users, because we want to make sure that they always have the best experience when coming into our app. Again, we're laying the groundwork. This is something that will take time and take teamwork, and we hope that you've learned something from a really simple framework on how to get started. As you can see, we're wondering what's next, and this graph shows that there might be a point of diminishing returns with 100% code coverage. Even though it's really enticing, you have to ask the question of, is 100% indicative of the customer experience? So we are really focused on making sure we deliver to our customers, and that might actually mean slightly less than 100, and prioritizing their requests and prioritizing making sure that they don't see the same bugs twice. There's lots of different types of testing, and we've just discussed a couple. It's something that we are growing and hoping to continue to improve. So please do reach out to Arun, and we hope to get there someday. Thank you so much for coming to our talk. We look forward to hearing from you in the Q&A.